All right, everybody. So this is the review for the Unit 2 quiz. I'm just going to go through the slides that you had as the practice with all the answers. So you have the answer key and the explanation of each question. So first, according to the periodic table, how many neutrons are in a calcium atom with an atomic mass of 40? So we have to keep in mind two things: atomic mass of 40 and that this is a calcium atom. Remember that the atomic mass equals the protons plus the neutrons. Well, in order to find the protons, we need to look up the element on the periodic table. Calcium is right down here, and it has 20 protons. That's its atomic number, 20. That means 20 protons. And if the protons plus the neutrons is 40, and the number of protons is 20, we would do 40 minus 20 equals 20 neutrons. So the answer here would be choice C. All right, according to the periodic table, the neutral atom of what element has 9 protons, 10 neutrons, and 9 electrons? So for this one, if you're looking up an element, right, if all you want to know is what element this is, the only number that really matters is the number of protons, because that is the periodic table number, the atomic number. So the element with 9 protons is element number 9 on the periodic table, which is fluorine. Choice C again. If iron reacts with sulfur to form a compound iron sulfide, the properties are most likely what? Well, this goes back to our conversation about what are elements, compounds, and mixtures. And it's important to remember that one of the things about compounds is that when you combine elements, you typically get properties that are different from the elements that make up the compound. Now, there may be similarities, right? You may have two gases that combine to form a different gas, but the properties of the compound varies and differs from the properties of the elements that make it. So we've talked about hydrogen and oxygen make water, right? Hydrogen and oxygen are both gases. Water is a liquid at room temperature. So the properties can be very different. Salt water is, well, it's definitely not an element. We want to be careful that it's not a compound because it's salt. You kind of look at this as salt plus water, right? So it's not a compound. It's not an atom. It is what we call a homogeneous mixture, which is also referred to as a solution. Okay, it's a mixture because the salt and the water are combined, but they are not chemically bonded to one another, forming a compound. Again, as we talked about before, if you boil the water, what's left is the salt. You take the water away as steam, and the salt is still there. It's still there. It hasn't been turned into something else. It's just been mixed with the water, and salt water is homogeneous because it's uniformly distributed. The opposite would be heterogeneous, which is sort of just jumbled together. Which of these is a molecule? Well, the first thing you want to look for is a molecule has to have at least 2 atoms. So the first choice, helium, helium is just an atom, so that's not a molecule. Oxygen is an element, but if you look in here, it's labeled as O2. It's 2 oxygen atoms bonded to one another. So that definitely qualifies as a molecule. And then carbon monoxide is actually 2 elements. That's a compound made of 2 elements that form a molecule, CO. So we actually have 2 options here, which means the correct answer is that both B and C are classified as molecules. Now, if the question was which of these is an element, it could be either helium or oxygen or both, because those are both made of only one type of atom. That's what makes something an element. Okay, here's 2 beakers. If they both have pure water, what is true about both samples? Well, boiling point is what's called an intensive property. Water boils at 100 degrees Celsius. Doesn't matter if you have a small amount or a large amount, the boiling point doesn't change. They do have different volumes. So I'm going to circle that and we'll just double check to make sure. Because this one is in a 100 milliliter beaker and it looks like it's marked right at the 100. This looks like it's 50, so it's 2 different amounts, 2 different volumes of water. Do they have different densities? No. Density is another intensive property. The density of water is 1 gram per milliliter. We use this in the aluminum foil lab. Density is a property of a substance which doesn't change based on how much there is. And different melting points. Again, water melts at 0 degrees Fahrenheit. 0 degrees Celsius. So whether it's a small block of ice or an iceberg, they both start to melt at 0. Now it takes longer for a bigger chunk to melt, but that doesn't mean that it melts at a different temperature. It just takes more energy to melt all that water over time. But as soon as you get above 0, ice starts to melt. What is the correct term for a group of atoms that all have the same number of protons? Okay, so protons here, remember protons equals atomic number, which is the definition of an element. An element is made up of atoms of the same type, the same number of protons. That's what defines an element. Isotopes are atoms of the same element with different neutrons. Molecules are groups of atoms bonded together. And an atom is a single particle with protons, neutrons, and electrons. So elements are made of atoms, but if you have a group of atoms, that would be an element. The mass number of an element indicates which of the following? We already talked about this. The mass number is the protons plus the neutrons in the nucleus, which is choice C. Okay. Electrons don't really impact the mass. Protons are the atomic number, but not the atomic mass, because the neutrons contribute. And protons and electrons, again, the electrons don't affect the mass. The protons are just the atomic number. Which of the following explains why water is a pure compound? Okay. It is composed of more than one element, right? Water is H2O, so that's a possibility. It's composed of 2 or more elements that retain their properties. Well, we already talked about this a little bit. Hydrogen and oxygen are both gases. Water is a liquid at room temperature, so they don't have the same properties. It is composed of 2 or more elements and has new chemical properties. So this is one of those cases where this answer is not entirely wrong, but choice C is the most correct answer. Okay, it can be separated by physical means. No, that's not true either. So being composed of more than one element, so you could, in theory, say you could have 2 elements that are mixed together. Like you could take sulfur and carbon and mix them together, and you would have a mixture made up of 2 elements, but they're not bonded together. So that's why answer C is the best answer here. There's a lot of answer choice C's on here. That doesn't mean the test is going to be the same. Don't just pick C for everything. Which of these describes the change from a neutral atom to its ion? Okay, this is tricky because there's 2 parts to this. One is that electrons can either be added or taken away from an element or from an atom, and whether or not you add them or take them away gives you the charge. Okay, and it has to do with both the positive and negative and the number of the charge. So we have to look at both parts of this. So a fluorine atom loses an electron to form F with a -1 charge, fluorine with a -1 charge. When you lose an electron, you get a positive charge. Okay, lose it sounds like you're taking something away. Shouldn't it be negative? What you're taking away is a negatively charged particle. So you're subtracting a negative, right? When you subtract a negative in math, it turns positive. So this is wrong because the charge here says negative and taking away electrons makes it positive. A sodium atom loses 2 electrons to form Na1+. Okay, so this is in the right direction. Losing electrons makes you positive. But if you lose 2 electrons, it would be +2. So that one is false. Oxygen gains 2 electrons to form O with a -2 charge. Now we're talking about both parts being correct. Gains 2 electrons makes it negative, and the fact that there are 2 of them makes it -2. So I'm going to circle this one. And just to show you the last one, magnesium gains 2 electrons. That should make it negative. Okay, so the number here is right, but the charge is wrong, so that's why this answer choice would be invalid. All right, which of these best describes isotopes? Atoms with a different number of protons? No, that's different elements, not different isotopes. Same number of protons, but different numbers of neutrons. That's what we want to look for. Okay, protons is what makes it an element. Neutrons is what can make it an isotope. This atoms with the same number of protons but different number of electrons, those are called ions. So that's something that can happen, but it's not what the question was asking about. Same number of neutrons but different numbers of protons, that's really kind of the same as the first choice, right? Different protons makes them different elements, not different isotopes. All right, what is different about each of these oxidation states? And you don't even really need to know what the oxidation state term means. If you look up here, these are all, first of all, these are all Mn, okay, which means they're all manganese. What's different is these charges up here. And as we just saw 1 or 2 questions ago, changing the charge comes from changing the number of electrons. So really the first choice here, the number of electrons orbiting the nucleus, is what's different. Different charges means that the number of electrons has changed. Again, you can't change the protons, otherwise they wouldn't all be manganese. Changing the number of neutrons makes them isotopes. These are not isotopes up here. These are ions. So we just want to keep those two terms distinct. Ions means the electrons have changed. Isotopes means the neutrons have changed. Elements means the protons have changed. The atomic number would be the same as changing the number of protons. All right. Which of these statements is true about these two atoms? X has 8 protons, 10 neutrons, 8 electrons. Y has 8 protons, 10 neutrons, 10 electrons. So first of all, they both have 8 protons. So they're the same element. So once they're the same element, we can cross off this one. And this says oxygen and neon. That's 2 different elements, so we can cross that off. So now we're trying to figure out, is it an isotope or an ion? So remember, isotopes have different numbers of neutrons, but the same number of protons. These have the same protons and the same neutrons, which means they are not isotopes. Ions have different numbers of electrons, so that makes these ions. Okay, electrons makes it ions, neutrons makes it isotopes. Protons makes it elements. Subatomic particle description. Protons and electrons do not make up the mass. We've already talked about that. Electrons don't affect the mass. Protons are positively charged. That's true. And have less mass than an electron. Nope, that's false. Electrons have almost no mass. Neutral atom has equal protons and neutrons. Nope. Protons are positive, neutrons are neutral. So the number of neutrons and protons is not related. They do affect the mass, but you don't have to have an equal number. Electrons are negatively charged, yes, and have less mass than protons, yes. So those are both true, which makes this the correct answer. Which of these has a charge of +1? So this goes back to the protons and electrons making ions. So in order for there to be a charge, protons, remember, are positive, electrons are negative. So when you count the protons and electrons, if you have the same number, there's no charge. Right? So for example, here I have 1, 2, 3, 4 protons and 1, 2, 3, 4 electrons. So 4 plus, 4 minus, that means that's a neutral atom. So it's not that one. This one has 1, 2, 3 protons. That's positive, and 1, 2, 3, 4 electrons, which is negative. So when you put those together, you actually get -1. So that's not it, because we're looking for +1. This one's actually the same as choice C. There's 3 protons, right, +3, and 1, 2, 3, 4 electrons, which are negative, so that'd be -1. So we're down to our last choice here. But just to show you, we've got 1, 2, 3, 4 protons, 1, 2, 3 electrons. 4 minus 3 is +1, which is the correct answer here. So that was choice B. Which of these causes an object to have a negative charge? Okay, and we're just talking about atoms, really. Protons are removed. Nope, don't do that. The protons don't change. Protons are added. We don't change the protons. Electrons are removed. Remember, if you take away a negative, double negative makes it positive. So that's not the right answer. Adding electrons to an atom makes it negative because you're piling on more negatively charged stuff, which changes the balance of positive and negative. Okay, more electrons means more negative charge, and the protons don't change ever. So if you have the same number of protons and you add extra electrons, there's more negative than positive, which makes it a negative ion. All right, which of these is the difference between an element and a compound? This first one is backwards, right? Elements do not have more than one type of atom. Compounds do have more than one type of atom. Element can't be separated physically, but a compound can. No, compounds cannot be separated physically, only chemically. An element is always the same, but a compound has different compositions. This is a tricky one because a compound does not have different compositions. Okay, a compound has to have a consistent composition. It's in the definition of a compound. Okay, it always has to be the same. CO2 is always carbon and 2 oxygens. Water is always 2 hydrogens and oxygen. So that one's a little tricky. You can have lots of different compounds, but they're different compounds. A compound by itself does not have a different different composition. So the last choice is the only one left, but again, an element is all one type of atom, but a compound is made of 2 or more different elements. Okay, so compounds are more complex than elements. Which of these boxes contains only a compound? So you have to remember what is a compound versus an element versus an atom, right? So this first box has several molecules of 2 atoms, but they're all the same type of atom. So that's an element. This has this group of 3, which is 2 different elements. So that's a compound. But then it also has these dots over here, which are individual atoms of an element. So only a compound? No, that has a compound and an element. This one is all dots of the same kind, so that's just an element. So the one over here, obviously the last one left, there's 2 different elements, and there's nothing else. Everything else in here is the same composition. Again, going back to what that means. Composition means what's it made of. All of these groups of atoms are made of the exact same combination of one larger blank dot and one filled in dot. So that makes it a compound, and that's the only thing in that box. So that's choice D. All right, last one. Which one only contains molecules? Well, this one contains groups of 2 atoms. They're not all the same, but the question doesn't say that. It says only molecules. So this one's definitely a possibility. B has molecules, but it also has these individual atoms, so that's not correct. D is the same thing. It's got some molecules. It's also got some atoms of different elements, but the question was only compounds. So what about C? C has all molecules and all the same molecules. So this would be an example of something that's a compound by itself. This is a mixture, but it's a mixture of molecules. So both A and C are examples of groups that only contain molecules. Right, so how many different elements are in the compound ammonium phosphate? So again, you have to remember when we're looking at formulas of compounds, and on the periodic table for that matter, every capital letter represents a different element. Sometimes there's a lowercase letter because there's a 2-letter abbreviation, but every element only has one capital letter. So if we look at this formula, we have capital N, capital H, capital P, and capital O. All capital letters and a total of 4. Now, this question asks about elements. So all I need to do is count up the capital letters. In this case, that's 4. A different question would be how many atoms are in this compound. In that case, I have to look at the little numbers down here as well. Okay, the little numbers don't change the number of elements, but they do change the number of atoms. So in this one, I would have 1 nitrogen, 4 hydrogens, 1 phosphorus, and 4 oxygens for a total of 10 atoms. Okay, so that would be another type of question that I could ask. But in this question, it was only about the elements, and that is just about the capital letters. Okay, if you have sand and iron filings, how could you separate them? So again, separating mixtures is about taking advantage of the different properties. One thing that you could do with iron is that it's magnetic, and sand is not. So if you had a pile of sand with some metal filings, iron filings in it, and you ran a magnet back and forth through the sand, the iron filings would stick to the magnet and the sand wouldn't, and you would be able to actually separate out the iron filings that way. In different combinations, you might use distillation. You guys, some of you did that for one of the discussions. Boiling water, it separates the water and the salt in salt water. You could filter out, if you had sand and water, you could use a filter to let the water go through and trap the sand behind it, and that would be another way to separate. So there's all these different ways of doing that. Okay, looking at the solubility chart here, which of these is saturated at 30 degrees Celsius? Okay, so 30 degrees Celsius is this line here going up. So we're looking for something on that line. So 12 grams of KClO3. So KClO3 is this line. And then the other one that it talks about here is NaCl. NaCl is this line here. So at 30 degrees, 12 grams of KClO3. Well, if I follow this line here, the 30 degrees up to the KClO, it hits right above the 10. I mean, you could argue about where it is exactly, but it's pretty close to 12 grams. And this chart is based on 100 grams of water. So the line represents saturation. So if I hit that line at 30 degrees, that means at 30 degrees, roughly 12 grams would be a saturated solution. The other options, 12 grams, the same amount, but in 200 grams of water? Well, no, because in 200 grams of water, you could double it and you'd be somewhere up here around 24. 30 grams of NaCl. Well, NaCl, again, is that green line. The 30 is down here. So 30 grams at 30 degrees would be below the green line. So that's not saturated. And then 30 grams in 200 grams of water would be even less saturated because you could get twice as much in 200 grams of water. So just to carry that out. Okay, a similar question, but slightly different look at it. So we've got NH4, ammonium chloride, and H4Cl. So that's this line. Try to trace it as best I can. Okay, so that green line is the one we're looking at. And it says we start at 50 degrees with a saturated solution. So that's right here, 50 degrees, touches the line at 50 grams. So I'm starting with 50 grams of stuff dissolved in the water that makes it saturated. And then I drop the temperature down to 10 degrees. Well, at 10 degrees, I hit that green line between the 30 and the 40. Okay, so I'll say, let's say it's somewhere around 35. The exact amount is arguable. It's probably a little less, more like maybe 34. So what the question is if the temperature goes from 50 down to 10, the amount of stuff that the solution can hold goes from 50 down somewhere a little bit above 30. So the difference between those, that amount of stuff would have to come out of the solution. It's called precipitating out. It would turn back to a solid. You know, the exact answer might not be here, but it's somewhere between 10 and 20. So it's not 5, that's not enough. 30 and 50 is way too much. So it's about 19 grams. And again, that's an estimate. You can argue about where the line exactly is, but all the other ones are way off base. So that's the closest answer. All right, dilution problem. If I dilute 5 mils of 0.15 molar NaCl to a volume of 5 liters, what's the final concentration? So we're using, first of all, the dilution equation, M1V1, molarity times starting molarity times starting volume equals final molarity times final volume. The little trick that they put in here is that one of the volumes is in milliliters, the starting volume, and the final volume is in liters. It doesn't matter if you have milliliters or liters, but they do have to be the same. You could do this either way. You could convert the liters to milliliters or milliliters to liters. Converting milliliters to liters means, you take the 5 and you move the decimal point 3 places, so you end up with 0.005 liters. So let's do that because we've talked about converting milliliters to liters. Starting concentration, M1, starting volume, V1, final volume, V2. That's the 3 pieces I have. The question is, what is the M2 concentration at the end? So plug in the numbers. Starting concentration is 0.15. Starting volume is 0.005 liters. That equals our unknown concentration times 5 liters. All right, so to solve, I'm going to divide both sides by 5 liters, which cancels it out on this side. When I carry out that math, I end up with 0.00015 molar, which was choice A. And if you didn't convert the milliliters to liters or the liters to milliliters, you probably would have thought, well, it's none of these because there's none that match, because your decimal point would have ended up in the wrong place. So this is just a vocabulary. Unsaturated means it's not yet saturated. It is not full. It is not holding as much solute as possible. Exactly as much as possible is saturated, and unstable because it's holding more solute than normal, that would be supersaturated. Okay, so the definition of unsaturated means it hasn't dissolved as much as possible yet. Okay, what is the molarity of? So molarity equals moles per liter. This question gives us the moles and it gives us the liters. So all we have to do is plug in these numbers. We're given them in the correct units. So molarity equals 1.457 moles in 1.5 liters. So all we have to do now, because we've got moles, we've got liters, that's what the question asked for, or the formula asked for, we divide that down, and we get 0.97 molarity, or moles per liter. Okay, so that would be the final answer here. What is the molarity? Sorry, this came out really blurry. I had to blow it up. 4.25 grams of ammonia in half a liter of solution. So the trick here, we got liters. Remember, molarity equals moles per liter. We've got liters, so we're good there. But we didn't get moles. Instead, we got grams. So you have to convert the grams to moles. Moles equals grams times molar mass. Okay, so the grams we got was 4.25 grams. Molar mass, we have to look them up on the periodic table. That's 14. It's blurry, but that's 14. Hydrogen is always 1. Since it's NH3, I have to do the hydrogen 3 times. So it's 14 plus 1 plus 1 plus 1, which is 17. So that's the molar mass. So to get the moles, I do 14.25 divided by 17 grams per mole, which is molar mass. That comes out to 0.25 moles. Okay, so now that's not the answer, but now I can take that and put it into my numerator. Molarity equals moles, which we said is 0.25 moles. And we have the liters, which was given to us as 0.5. So we do 0.25 divided by 0.5, which is 0.5 molar. All right, and then the last one is just a quick thing about chemical and physical changes. Remember, a physical change just means you're altering sort of the appearance. You're not turning the substance into anything else. You're not creating any new substances. So anything that makes the pieces smaller or boils or melts, those are sometimes tricky because it looks like you're changing it, but you're just turning it from a solid to a liquid to a gas, or the other way around. So boiling, melting, freezing, tearing, grinding, breaking, those are all physical things. Bending, right? Those are all physical properties, or rather physical changes. So tearing a piece of paper, when you take a piece of paper and you tear it up, you're just making smaller pieces of paper. You're not turning the paper into something else. That's a physical change. Burning a candle, on the other hand, you're actually, first you're melting the wax. That's a physical change. But then because of the combustion, you're actually taking the hydrocarbon that's in the candle and you're burning it and creating carbon dioxide and water vapor. So you get something different. That's chemical. Boiling water. Boiling, freezing, any of those phase changes from solid to liquid to gas, those are always physical. Tarnishing copper, if you don't know what that means, it's kind of the same as rusting. And rust is when you combine oxygen from the air with the metal. That's a chemical change. It produces a new compound, which is a combination of the metal oxygen. It's called an oxide. And then chopping wood, you're just making smaller pieces of wood. You're not turning the wood into something else. Then when you throw it in the campfire, then you're doing a chemical change. But just chopping the wood by itself is not a chemical change. It's a physical change. So there you go. I just alternated, oddly enough. I didn't mean to, but I did. And then I think on the sheet that you guys had, there was an extra blank down here, just a copy paste error. Sorry about that. Don't worry about it. All right, so those are all the questions and the types of questions that will be on the quiz. Whatever you need to do to study to prepare, using those questions as a guide, that's what you can expect to see on the quiz.